Okay, so this is the model which we have designed in SAP. So before we start the now for the same model we have different options. For example, we can design the isolated footing, we can design the combined footing, we can design the strip footing, and at the end we can design mat foundation. And I told you how you can come to know that what type of foundation you need. For example, you start from isolated footing, but the load is very high, and when you find out the size of footing, it is very big. For example, center to center spacing, please see in the XY plane. For example, the center to center spacing of these two grids is around 7 meter. Okay, and if you find out the size of mat foundation, size of isolated footing, it comes out to be like 6 meter, 6 meter by 6 meter. For example, if there are a high number of stories and the under the column the value of dead load and live load would be heavier. So what will be the result would be bigger footing size, because you know area of footing is equal to total load dead plus live divided by the bearing capacity. And if they start overlapping with each other, then we may combine. But still, again, the bearing pressure is not satisfied. You need bigger size. So then you can again go for the mat foundation. For your case, I'm sure the isolated footing will work. I'm sure the isolated footing will work. For 3 to 4 stories building, isolated footing is going to work. We will test, but as my purpose of this lecture is to teach you the design of mat foundation, so we will proceed with the design of mat foundation. So always before design, it's better to run the analysis. Run analysis. Run now. Okay. It's done? No. So weather is getting hot day by day, you know, and but it's nice at evening. Yeah, if you go out, there's a very good breeze coming in the parks. Okay. So now we can export the safe.f2get-x file. Export floor loads and loads flown above. Okay, this option is now on. This is the elevation because we want to export floor. So I will select all the load cases, make it okay, and save. I give the mat footing. Save. Okay, now we will go to save, and we will import this save. Sorry, it's not open. Import. Okay. So this is the grid with the, now these are your supports. All these are your supports which you have already assigned in the SAP. You have assigned the fixed support, so all these supports will appear over here. Okay, click on this joint, right click loads. See, now you have all the reactions from SAP to SAFE. Why I did analysis? Because I want to have the reactions at the base of footing. So always do this step after analyzing the cell. If you want to see the reaction, there is another way by which you can click 3D and you can go to display, show loads, and all these loads will be here. That and that above. It means all the loads which are acting above are also included in this file, because we are working at the base. Show loading values, make it okay. If we right click, display, show loads, that above. See, when I click that, there was no load to display, because at foundation level there is no dead load acting. You understand? So all the loads which are acting from above, you will find the values. Now you can see there are several types of reactions here. If you want to see any, these are the only dead loads from above. If you double click here, you can adjust this coordinate system. These are the dead above, and if you go to the loads, and these are the detailed values.
Combine first.
So it will show you, for example, dead above, surface finish above, wall above, and now see here the size, load size. It is actually the size of column. Why you need this load size? Because you have to check punching shear. Because for punching shear you need the column size. So you can see here, this is the load size, and if for some column the load size is different, automatically it would be exported over here. Okay, now again I go to display, and if you want to see the earthquake above in XY, make it okay. You can see the earthquake forces. Okay, so it has all the forces. Uplift means the forces which are acting in the upward direction, and the gravitational forces which are acting in the downward direction. Okay, this is your display, and now we go to model the mat. We are going to model the mat. Sorry? You should have informed me before that I should say it. Okay. Okay, now please see. We have to define materials. Add new, for example, it is C30 megapascal concrete. And if you want to define new material, it's your choice. But let's use the same one, concrete 30 properties, 30 megapascal. Okay. In many cases, the foundation concrete quality is not as the quality of your columns and shear walls. So you may have lesser concrete quality. For example, you can have like C20, C21, 21 megapascal, but it's your choice. Whatever you want to use, just use it. For example, if you want to use like C20, 21 megapascal, just change 21, double click here, because you have to calculate 4700 under root FC prime yes, I should multiply here okay, and okay, you have one material now. Now define slab properties, add new property. Here you will select, you will say mat, and Material 21. Okay. This is the most important thing, because if you select this as a slab, it will consider as a slab. But if you select as a footing or mat, you can select any of these two, because for both the support will be the support of soil. For foundation and mat, the support will be the support of soil. But for the slab, the support will be the columns or beams. Okay, which one you want? Mat? Thickness of mat. Now, I told you that for your building case, the isolated footing is enough. And the thickness, if it is 600, it would be enough. Or even 550 will work. Let's see. It's a trial value. If it will fail, we can increase it. Make it okay. Property name mat 600. Okay. Okay. Define. Now, if there are beams in your mat footing, you can define those beams. But if there are no beams, there is no need to provide the beams. Okay. Okay, but in the beam, I want to show you something. Let's see, beam, add new property. Now, you have several types of beam here. T-beam, L-beam. Okay, and in the new, there are more options, and now you can see that there are several types of options by which you can play. For example, rebar in shear, rebar in FY for shear, FY for longitudinal steel, and width, BW, web width is basically BW. Flange width, you can also, flange dimension from slab. I told you how to calculate it. 16 times HF plus BW. You remember? L over 3 or L over 4 or L over 2. I have given you all these things. Anyhow, if you click inverted, it would be inverted T-beam. But we in our mat footing there are no beams, but for explanation I have told you. But there is a wall. You can see here. There is a shear wall. If you want to see the effect of wall, the effect due to the presence of wall, of course there will be some changes in stiffness. You can provide wall, but if you just want the forces, your forces are already in your model. I'm again repeating, I will not give this extra lecture to the senior design students. So please keep in your mind that this is going to be your official senior design lecture. Okay? You will not be explained by your advisor for design of building or footing. Okay, next, for example, but if you want to see the wall, you can define a wall. For example, okay, let's take a wall. We define a wall, we have a shear wall. Okay, use the same material, but if you want to use a different material, you can have the different material. Wall thickness was how much? 150. And include automatic rigid zone area over wall. If you check this, it will change the stiffness of your foundation. Keep it unchecked. Wall takes yes, because shear wall have to take out of plane moments. Make it okay. This is your shear wall. Okay. Now we are designing a mat without beams. Now let's go to the load cases or load patterns. Soils, but before that, the most important thing for the foundation is the soil subgrade properties. For example, add new property, you say Q allowable bearing capacity. Here, you have to give, what are the units for the bearing capacity? Kilopascal or kilonewton per square meter. What is here? Kilonewton per cubic meter. And it is saying subgrade modulus. Have you studied the modulus of subgrade reaction in your foundation course or geotechnical course? It is basically, the modulus of subgrade reaction is basically QA, allowable bearing capacity, divided by allowable settlement. Divided by allowable, how much settlement you are going to allow. And allowable settlement, for example, for isolated footing, it is 1 inch or 25 centimeter. Or in some codes you can find it 1 centimeter. Allowable settlement. For mat foundation, the allowable settlement is 2 inch. It is 50 millimeter. It is 50 millimeter. So now I tell you how to calculate. Please keep this. This is the most important step. How to calculate the modulus of subgrade reaction, the allowable bearing capacity. For our problem, the allowable bearing capacity is 200 kilopascal. 200 kilopascal means kilonewtons per square meter, divided by allowable settlement in meter. So allowable settlement is 50 millimeter, so it will become 0.05. Okay. This is not the bearing capacity. This is the modulus of subgrade reaction. Modulus of subgrade reaction is allowable bearing capacity divided by the allowable settlement. Okay. Then go to define load patterns. All your loads will be already over there. We need this load basically, dead and above, because the dead load at footing level is 0. But you can keep it, because now footing will have dead load in the same. Okay. So load combination, at least one load combination I must need, and that is service load combination. Service. Because we check the size of footing, we check the pressure at service loads. That, okay, 1. Dead surface finish wall, earthquake X, earthquake Y. Actually, I'm sorry. For service load, we have to only consider the dead and live load. There is no need to consider these loads. Okay. Okay, I cancel and add new combination again. Service means only dead and live. Dead, surface finish dead, wall dead, and live load. Make it, if you check uncheck, it's not going to be okay. Okay, define. Now you have to draw your mat foundation. We have defined almost all of the things. Now please see how to. It's very easy. Mat is present everywhere. You can select any of these commands. For example, select this one and property mat 60. Click here, and enter. Your mat is there. Okay. Now these are the center lines. Please see, this is the important thing. but your footing, I mean this is the location of your column. So you have to extend your footing outside of your column. How you can do it? It's very easy. Either you can draw it outside, or there is one thing, just select it and go to edit areas, expand or shrink, and give how much you want to extend. For example, the one thing you keep it exactly at the outer edge of your column, means 450 divided by 2, 225 on all sides. But if your property line is far away, if your property line is away, you can extend up to your desire. For example, how much you want to extend? Exactly according to the column edge, or you want to extend some more. Okay, let's extend first 225. I mean exactly at the edge of column. Now you see it's extended. Can you see? It is extended 225 from here. Okay, now next. So you have drawn, you can see you're putting in 3D. This is your foundation. If you want to see the extruded view, click extrude view. See. There is even no need to draw the wall. I thought maybe I have to draw the wall, but it has, because as I have already drawn the wall in the SAP, so it is there. Okay. So this is your mat footing. I just go to the normal view, uncheck this. If you want to change the display color, you can go to the options, graphics color. If you want with the black background, it would be now like this. Okay.
So, what about
I'm coming to that. Just give me some time. Okay, next, if you want to design it, you need the design strips. Okay, so you have to define the design strips. You can select the auto, or you can give a fix. For example, let's see what the program says to us. Program is saying this one, but I don't want this. I delete. Similarly, maybe I'm not interested in this strip. So I will get steel for this strip, this and these strips. I mean, I will get reinforcement for this strip. Similarly, go to edit, add design strips in the Y direction, keep it auto. Again, I am not interested in this strip, not in this. Okay, so you can edit. You can again, if you want to draw any strip, you can draw. Okay, next. So you have now the design strips. Now you have to set the design code. Minimum cover, clear cover top for let's give it clear cover top, like minimum clear cover like 40 mm. Clear cover for the foundation, the bottom cover is 75. These are the preferred bar sizes according to SI. Okay. Display detailing. Code is set. Detailing preferences. This is how you want your bar marks. MK1, 2. Keep all these things same. If you want to change something, you can change. Okay. Detailing for slab and mat. These are the curtailment rules. You can find these curtailment rules in the code. You can pick those curtailment rules and you can put it here. If you want to change, for example, if you want this extension to be like 200, you can keep it 200. And overlap, again you want, this overlap is basically LD, development length. You can see this value from the code. And rebar selection, smallest bar size number 10, biggest bar size number 25, okay. Minimum number of bars 2, preferred bar size number 19. Actually this is SI, so SI is number 18. Okay, now we are ready to run analysis. Save, mat footing, design. Because that was F2K file. The actual save file is FDB file. So you have to save it again. Now it will run the analysis. Done. You are looking the deformed shape for dead load. Okay, but first of all I am interested in the bearing capacity, that either the size of footing is okay or not. How I can see? Go to display, show reaction forces, it should wait, display, close, show loads, let me run analysis and design together. This option should be on, I mean soil pressures. You know why it is not on? Because we missed it. I again go back, make it okay, unlock XY. Now I have not assigned the soil support to the mat. Select this, go to assign, properties, first assign the mat 60, okay. Now it is mat 600, select it, assign, support, Q allowable, okay. Now the support is there, okay. There is no need to assign the loads because the loads are already there, okay. If you want to assign any load as a separate, you must have to. Okay, now again run analysis and design. In 3D. Okay, now you can see but I told you that I'm interested in the soil pressures, so go to display, soil pressure, okay. Okay, so how much is the soil pressure? Now you must have to check your units, in what units you are checking your soil pressure. It is in Newton. make it kilopascal.